औज़ुबिल्लाहिमिनश्शैतानिर्रजीम बिस्मिल्लाहिर्रहमानिर्रहीम। अस्सलाम वालेकुम क्लास, कैसे हैं आप लोग? खैरियत से हैं? उम्मीद है आप लोग ठीक ठाक होंगे। क्लास, दिस इज our last recorded lecture, and after that inshallah you will be in exams, and I hope that the subject that I have delivered will help you out in the future, and the best of luck for the exams. So the last topic of our course is the radio wave propagation. In this wave propagation, we will discuss the propagation modes and their types and slightly of their details. Okay, first of all, what is mean by propagation? The propagation is basically the traveling of radio waves from one point to the other. There are very different methods by which the radio waves travel between 2 points. One is the direct from one point to the other. Second is to follow the curvature of the earth, that is the round shape of the earth. The wave will follow this shape if the distance between the transmitter and receiver is more or is greater. Third is the wave become trapped in the atmosphere and traveling longer distances back from atmosphere to the receiver, which includes the different atmospheric layers, and one of which is the ionosphere. So basically, that is the mean of propagation of electromagnetic waves or radio waves. There are basically three modes available for the propagation by which the waves travel by these methods. There are three methods. Number one is the ground wave propagation. Number two is the sky wave propagation. And the last is the space wave propagation. These propagations basically are illustrated in this figure. The first you see that is very near to the earth or very near to the ground is the ground waves. The second one is just above in the atmosphere, that is around the troposphere layer of the atmosphere, that is called the space wave propagation. And the last but not the least is the sky wave propagation. In ground wave propagation, the wave or the signal follows the shape of the earth from transmitter to receiver. The space waves are directly or the straight line between transmitter and receiver, and the sky waves are basically the uh, reflection of the signal from transmitter to the ionosphere and back to the, after reflection, it reflects back to the receiver. These are the radio frequency bands. We have discussed these bands in the start of this course. These are the radio frequency bands by which the signal travels in some specific frequencies. Now that is the illustration of the ground wave propagation, in which the wave basically follows the curvature or the surface shape of the surface of the earth. This from transmitter to receiver, signal propagates. Groundwave propagation basically follows the contour of the Earth. They can propagate considerable distances, means the distance should be mean they can travel more distances as compared to other propagations. Frequencies up to frequencies up to 3 megahertz can be best propagated through ground waves. Example is the AM radio. Frequencies up to 3 megahertz, the most important method of propagation is by ground waves. They are vertically polarized. They follow the curvature of the Earth to propagate far distances beyond the horizon, that means beyond the look of the transmitter. It relatively requires high power. Radio wave follows the Earth's surface. AM broadcast during the day is the best example. Work best at lower frequencies. Relatively short range communication is done by ground wave propagation mode. Second is the skywave propagation. In skywave propagation, signal reflected from ionized layer of atmosphere back down to Earth. Signals can travel a number of hops back and forth between ionosphere and Earth's surface. Reflection effect caused by refractions. We will look into the figure there. That is the sky wave that basically goes above the atmosphere and reflected back, usually from ionospheres, back to the receiver. Reflection effect caused by refraction. Example is the amateur radio or CB radio. In skywave propagation, as from the figure, there are different layers of the atmosphere. The basic four layers are the ionosphere. First is the ionosphere, having the distance above the Earth's surface around 80 to 720 kilometers. Then down to the ionosphere is the mesosphere, which is from above the Earth's surface from 50 to 80 kilometers. Then stratosphere, which is above the Earth's surface from 12 to 50 kilometers. And the troposphere, which is the nearest and is from above the Earth, it is from around 12 kilometers. So these are the different layers of the materials which reflected the signal, and that basically used to communicate the sky waves. Then we have the second type that is illustrated in the diagram as the space wave, which is also called line of sight communication. That line of sight communication is very important as compared to the mobile and data communication. So this space wave is called the line of sight propagation. In this propagation mode, the transmitter and receiver are logically appears to see each other. That means they are located beside each other, and it seems that they are viewing each other. That is the basically line of sight propagation. Properties are signal travels in a straight line from transmitting to receiving antenna, useful in very high frequency and ultra high frequency ranges. Examples are television and FM AM broadcast. Signals are easily reflected, causing problems in mobile operation. Transmitting and receiving antenna must be within line of sight. That means they are actually logically aside of each other. Refraction, bending of microwave by the atmosphere. Velocity of electromagnetic wave is a function of the density of the medium. When wave changes medium, speed changes definitely. That is the refraction law. Wave bend at the boundary between mediums. That also the refraction law. So basically, these are the features of the line of sight propagation. Line of sight propagation is basically mostly used in mobile radio propagation, mobile radio communication. It is an important controlling factor in wireless communication system. Transmission path between transmitter and receiver can vary in complexity, as line of sight is the simplest and easiest way to control mobile radio channels. Why should we have propagation model? That is a big question. With propagation models, we can provide installation guidelines, we can mitigate interferences, or we can design better wireless systems. Wired channels are stationary and predictable. Radio channels are extremely random and have complex models. Basically, in mobile radio communication or mobile signal propagation, mobile devices are extremely random. Definitely, they are movable. They are mobile and have complex models. As we talk about the mobile communication, modeling of radio channels is done in a statistical fashion based on measurement for each individual communication system or frequency spectrum. Basically, in mobile communication, modeling of each user radio signal is based or modeled in a statistical method. There are different propagation models available. Basically, the propagation models have the objective to predict the average received signal strength at a given distance from the transmitter, or to predict the variability of the signal strength at close spatial proximity. That means propagation model has the objective to predict the mobile user signal strength at some distances or at the closest to the transmitter or receiver and their spatial location. So these are the basically propagation model objectives. The properties of radio waves that basically we are modeling for the propagation are easy to be generated. They can travel long distances without any loss or without minimal loss. They can penetrate buildings. They can be used for both indoor and outdoor communication. They can travel in all directions. They can be narrowly focused at higher frequencies using different parabolic reflectors or antenna that have been discussed previously in the previous lectures. There are various frequency dependencies that can affect the efficiency of the propagation of electromagnetic waves or radio waves. They can behave like light at higher frequencies. Difficulty in passing obstacles. Of course, if the frequency is less, the signal cannot pass the obstacle. Rectilinear property, more direct pass. The efficiency will be greater if the signal is transmitted directly to the receiver without any obstacles. Observe, absorbed by rain, fog particles. The atmospheric conditions can vary the transmission efficiency. Behave more like radio at lower frequencies. Can pass opticals at lower frequencies. Power falls off sharply with distance from source. Definitely, if you move, if the wave travels greater distances, their power falls, subject to interference from other radio wave sources. These are some frequency dependencies. There are certain propagation mechanisms available. Reflection occurs when the electromagnetic wave impinges on an object which has very large dimension as compared to wavelength. Diffraction occurs when the radio path between the transmitter and receiver is obstructed by a surface that has sharp irregularities. Propagation mechanisms. There are different propagation mechanisms. One is the reflection, which occurs when the electromagnetic wave impinges on an object which has very large dimension. If the electromagnetic wave hit the object with very large dimension, reflection occurs, and diffraction occurs when the radio path between the transmitter and the second propagation mechanism is diffraction, which occurs when the radio path between the transmitter and receiver is obstructed by a surface that has sharp irregularity. That means diffraction occurs when the signal between the transmitter and receiver is being obstructed by an irregular sharp obstacle. Then diffraction occurs. Scattering is also a propagation mechanism which occurs when the medium has objects that are smaller or comparable to the wavelength. That is, scattering occurs. This propagation mechanism occurs when the medium has the receiver which is smaller or comparably smaller than the wavelength. Then the scattering occurs. This is the explanation of the radio propagation mechanism. This is defined as the reflection. This is a polarization which is defined so many times in this course. I again repeat it, as the polarization is basically the orientation of the electric field. As we know that the electromagnetic wave have both the fields, electric field and magnetic field. The direction of electric field defines the polarization. There are many types of polarization. There is vertical, horizontal, elliptical, circular, which I discussed previously. Polar, Polarization is also very important as compared to the propagation mechanism. This is a practical example of reflection model, which is stated as the ground reflection model, in which we can see that a car which is a transmitter, of the car which has a transmission system, that is transceiver, is basically transmitting from a tower, which is modeled as this reflection model. This is just to show you the reflection model. That is the example of the reflection. So this is basically the description of the propagation of the waves, and I hope that this lecture will be I've delivered this lecture to the best of my understanding, and I hope that you will also understand this easily. For any queries, inshallah, we will have a single session left for the Zoom. Inshallah, discuss these queries and the final paper. Thank you very much, and God bless you all. Take care of yourselves. We'll meet inshallah on the Zoom session. Thank you very much.